Hello, my name is Clemens. I'm the CTO of Persival, and today I'm going to give an introduction to the main ASAM OpenX standards for automotive simulation. A lot of tools in the automotive simulation domain have proprietary file formats. And that means, for example, you have defined a scenario to be simulated in one tool, and then you cannot easily run the same scenario in a different tool. And that's where standardized file formats and standardized interfaces come in. Because standardized descriptions of scenarios, of maps, of interfaces between models, of 3D assets help you to exchange all that, exchange your whole simulation between different tools, between different companies that use different tools. And the ASAM OpenX standards cover a whole area or a lot of areas when it comes to defining a simulation. In this tutorial series, I will mainly talk about 4 standards. The first one is ASAM OpenDRIVE. And OpenDRIVE answers the question or helps define where we are driving. So it's a standard to define road networks and road infrastructure. The second standard is ASAM OpenSCENARIO. It has 2 varieties, OpenSCENARIO XML and OpenSCENARIO DSL. But both help define the dynamic elements. So what are vehicles doing at a certain point in the simulation? What are other traffic participants like bicycles or pedestrians doing? You can define all of that in OpenSCENARIO. The third one is the ASAM Open Simulation Interface. It is an interface standard that defines how to transfer data during runtime of a simulation between different simulation models. So for example, you have a scenario player playing back an open scenario defined on a certain OpenDrive, and it plays that back. And during runtime, every step of the simulation, you can transmit the current state of the simulation, the current state of the environment, of all the dynamic elements to, for example, a sensor model that can then derive a sensor output. And that sensor output you can also transmit via ASAM OSI to the next element in your chain, maybe your object detection algorithm or maybe your behavior planning. So ASAM OSI defines interfaces between all the different components of a co-simulation. And the last one is ASAM OpenMATERIAL 3D. And it defines what the environment actually looks like, not only to the human observer, but especially to perception sensors. So OpenDRIVE, OpenSCENARIO are very abstract definitions, and OpenMATERIAL 3D becomes more concrete. So it has a concrete definition of the geometry and of material parameters. So you can build up a whole 3D world with dedicated material parameters in certain wavelength for your sensors. So in this tutorial series, I'm mainly going to be using these 4. There are other standards in the ASAM OpenX universe, but those 4 are mainly used by me. And today, in this tutorial, I want to go a little bit deeper into OpenDRIVE and OpenSCENARIO. If you remember from the last tutorial, we set up a co-simulation using the AVL scenario simulator. And this is the same example from last time. So we have ES Mini as an open source tool for a scenario player. So it plays back an open scenario file. And we have connected to it our sensor model. Just a quick reminder what that looked like. I'm going to play back the simulation that already ran. And you see we have an eco vehicle here in the center, and we have one vehicle that is overtaking it and then cutting into the lane of the eco vehicle. And the sensor model is a front-facing sensor, so it starts to detect the object right about here. You see the detected object in green. Now let's go back of how was that actually defined. So how does ESMini as a scenario player know that that's the scenario that is to be simulated? And if you remember, we set as a parameter a path to an open scenario file. XOSC stands for ASAM OpenX Standard Open Scenario. And let's actually have a look into that file. So this path leads you to this resources folder. We just used the default example that comes with ESMini, and we have here an XOSC folder. There are also a lot of other examples, so feel free to explore also the other examples here. But we're using the cut-in example. I've already opened this here. So Open Scenario is an XML-based standard. So what we see here is an XML file. And let's go from the top down and see how this is defined. So first we see here, let's start here. We have the two vehicles. So we have the ego vehicle and we have the overtaker. And what you see here, that there's a reference to a vehicle catalog. And we have a host vehicle and a target vehicle, and those are just variables that are defined here. So we have the car white and the car red. And now we can go to the vehicle catalog. It's also in the XOSC folder here. So we have catalogs, and we have vehicles, and we have this vehicle catalog. And here, in a little bit more detail, the vehicles are defined. So we see here, first one here is the car white, that's our ego vehicle. And the vehicle catalog in Open Scenario lets you define different parameters for your vehicles. So for example, we have here settings for maximum speed, maximum deceleration, maximum acceleration. We see that we have two axles, front axle and a rear axle on that car. We see what the maximum steering angles are on these axles, wheel diameters, the track width, and so on. So you can define a lot of parameters for your individual vehicles. And the reason why this is separate in a vehicle catalog is that you can reuse it. So let's say you have a different scenario, but you want to use the same vehicles, you can do that and simply reuse the definitions of the vehicles from the vehicle catalog. So this defines the vehicles. We have two vehicles, our car white and our car red, with certain parameters. Now let's go further. Here we have a storyboard and the initialization of that storyboard. In the first step, we initialize our ego vehicle and our overtaker, and we teleport them to the start position at a certain lane. So I say, okay, it's on a certain road with the ID 0 and on the lane ID -3, and the overtaker is right next to it with the lane ID -2. And then we define our scenario, and the scenario is defined as a story in Open Scenario. So we have our story, cut in and break story, and it is separated into different acts, and each act can be separated into different maneuvers. So first we just set the speeds here. That's the first action, the first event. And then we have a second event, and that's the cut-in. So after we set initial speeds and the cars are driving straight, we want to define the cut-in. And the cut-in is simply a lane change. So what we have here is a lane change action that tells the overtaker vehicle to change lanes. And we have a lane change target that says go into the same lane as the ego. So relative to the ego lane, value 0 means same lane as the ego. And that tells the overtaker what to do, where to go, but it does not yet tell it when to start the lane change. And for that, we have a trigger. We have a trigger condition here. There are different trigger conditions available. This one is time headway. So at a certain time headway to the ego, it should start the lane change. After it has changed lanes, if you remember from the simulation, it starts to brake. So we have an event called overtaker brake event. And here we have a speed action, so it should change the speed to an absolute speed of 0. So it should actually brake to a full stop. And here we also have a trigger condition. Again, a time headway, and that's defined in the values up here. So we have the headway time for the lane change, and we have the headway time for the brake. And at a certain headway, it starts to brake. And that's our whole scenario definition. So now it's defined for every vehicle what it has to do in the scenario. Now maybe you're wondering, well, everything's relative to lanes, but how does ESMini know where the lanes are? We've not defined them yet, right? And that's where the other standard comes in. So this was OpenSCENARIO, and the other standard that comes now in is OpenDRIVE. And you can see here in the road network, we have a reference to an OpenDRIVE file. And you can find that, go back to the folder structure, we were in the OpenSCENARIO folder. You can also see an OpenDRIVE folder. OpenDRIVE files have the file extension XODR for ASAM OpenX Standard OpenDRIVE. And you can find here exactly this file is here in that folder. Let's quickly open that up. So here you see the definition of a road. So you have roads, and then each road is divided into lanes. In this example, we only have one road, but we have multiple lanes. And the lanes are defined here. Every lane has an ID and a type. So you can see we start at the edge, a type border, we have another border, we have a stopping lane, and then we have several driving lanes. And you see other parameters, like the width of the lane is defined, road marks are defined. For example, here we have broken road marks next to that lane. And that's all defined again in an XML format here. It becomes a little bit more intuitive when you visualize the OpenDRIVE. And there's an online tool, an ODR viewer, so odrviewer.io. And I've already loaded the XODR file. You just go to OpenXODR and load that file. And here you see the road, a very simple, slightly curved road. And when you zoom in, you see the individual lanes. And if you look to the spotlight up here, if I hover over a lane, you will get some information here. And start from the left one, that's lane with ID 7 of type border. That's what we just saw. We have another border next to it, and then we have the driving lanes, or the stopping lane, and then we have the driving lanes, just as defined in the OpenDRIVE file. And this is also what's referenced by ESMini. So if we go back here to the cut-in scenario and we say the ego vehicle should start on lane with ID -3 and the overtaker with -2, you can actually go into the OpenDRIVE visualization and look for that. And you see here that's lane -3 and that's lane -2. So they're right next to each other, the ego vehicle on the right and the overtaker on the left. And that's exactly what ESMini uses. So if I play that back, we can see the ES Mini visualization. Let me play that back again. Again, you can see that same road with the lanes. You can see the car white and the car red as defined in the vehicle catalog. And with the headway, it will overtake and then it will start to brake. And that's, in a nutshell, how OpenSCENARIO and OpenDRIVE work and how scenario players like ES Mini load and interpret that information. In my next video, I'm going to go more into detail how to actually create an OpenDRIVE and how to create an OpenSCENARIO, because yes, you can edit the XML file, but it's a bit tedious, especially for bigger road networks and bigger scenarios. So you need an editor for that. And that's what I'm going to show you in the next video. If you have any questions about these standards, feel free to leave a comment below. See you next time.